Welcome everybody. This class we're going to illustrate why this formula of xy is important for our constructions of the Pythagoras triple. Please recall that we actually derived this formula in the previous lecture based on the geometric construction in this table. And now, first of all, let's talk about the possible values of r here. Definitely r can be any integer 1, 2, 3, 4, etc. But it's gonna be too restrictive because r in general shouldn't be integer. We can freely change the location of this point on the x-axis, and r, let's try to do it this way. If we assume r to be a rational number, which basically means r is p over q as a fraction. Let's try to do it this way. First of all, we substitute this p over q into both expression, and now it's an exercise for you to do here. If you do the substitution correctly and a little bit of simplification, you should be able to arrive at this formula here. So now the first step to do, we try to give out some concrete examples here. First of all, let's say if r is the value 2 here, which basically means r is the same as 2 over 1, and it basically means that the value of p is 2 and the value of q is 1, and then in that case you replace p by 2 and q by 1 into the formula here. You should be able to tell that you arrive at the following two numbers as the answer for the values of x and y, 4 over 5 and then 3 over 5 here. So this one is really just one single example to illustrate how to replace the value of r into the expressions to get certain rational point on the unit circle. And it basically means that you can randomly choose any rational number of r, and then from there, by substitution, you should be able to get the rational point on the unit circle by this method. And basically all the rational points can be obtained by such a method. So now we have to go back to the original aim, which is to construct a Pythagoras triple. So please recall that a Pythagoras triple ABC satisfies the Pythagoras theorem here: a squared plus b squared equals c squared. And please recall that in that case, if you divide a and b by the c as the denominator, you're able to get 2 points, a over c and b over c. And we talked about it in a previous class already that this point is exactly a point on the rational on the unit circle, a rational point on the unit circle. So now a simple way to look at that, please try to compare these two expressions for the rational point of a unit circle here. Essentially speaking, I'm talking about that. Please compare these expressions with the expressions down there. Can you tell me something about that? Because of the fact that the denominator is actually a common one here, so it basically means that we can try to write down the expression ABC in terms of the following. So please note that in this expression, basically I take C to be p squared plus q squared, and that's how I arrive at that. Okay, so basically we are done. In the problem of finding a Pythagoras triple in a systematic way, we arrive at such a formula. Now basically means that if you replace p and q by any integers, and then you should be able to construct any Pythagoras triple. For example, the first one, if p is 3 and q is 1, can you tell me the value of ABC here in 1 minute? If you do the substitution correctly, you should be able to get that ABC are equal to 6, 8, 10 respectively. And definitely this example is a Pythagoras triple. You can check the relation here that 6 squared plus 8 squared equals 10 squared. To the next one, let's take a bigger example. Let's take B equals 10 and Q equals 1. So can you tell me the values of ABC in 1 minute here? So if your calculation is correct, you should be able to get that 20, 99 and 101 are the values of ABC respectively. So I hope that from this example where I chose a big value of P here, you can see that the formula is actually quite useful in finding such a Pythagoras triple, because such a triple 20, 99 and 101 is not something obvious for you to get, if you simply look at the relation a squared plus b squared equals c squared, it's not something you easily get such a triple by random guessing. So now basically I finished the video here because we have already got the way to construct a Pythagoras triple using this formula here. And next video we try to look at some other interesting examples of Pythagoras triple. Okay, see everybody next time. Thank you everybody.